Alright, so seems like we're live. Are we live? Checking, testing. Okay, seems like we're live. Yeah, I'm not sure about the video quality here, but yeah, let's just work with this quality. I hope you can still see something. Okay, so we're going to do this Codeforces Round 763 virtual contest. I haven't seen the problem before, so this should be my first time seeing these problems, and we're going to solve this, and maybe I can give some commentaries on my thoughts process and solving it. And I have a feed of my notes here, so you can see if I scribble something there. Okay, so let's do problem A. Problem A. Robots. Okay. So we want to clean this dirty cell, which the robot is initially at 1, which is here. What? Okay. 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 So we can just simulate this. I think there's no choice. The robot will just move deterministically. Okay. The time for the robot. Okay. Is it? I'm okay. Okay. Yeah. Wait. If there is a vertical wall in the movement direction, DC is reflected. Okay. Okay. So we can just simulate the process, I guess. What are we reading? NM, RB, RC, no, CB, RD, CD. Okay, and then initially it's at 1, and then we can just simulate the process, and then we keep the time needed, and then we check whether we have actually reached the destination, which is RD, or the second has reached CD. Then we break, otherwise we move. So if let's see. Oh wait, the RDC is the DRDC is the direction. Okay, so initially we are at RBCB. Okay, and then okay, got it. Okay, so I think we need to know what's the move as well. it's 1. Okay, and then if this causes it to go out of bound, we R. No, not R, sorry. What's it? M. This is M. And this is second. This is second. And then we go this. And then we print the number of moves. Okay, wait. Oh wait, currently we are at RBCP, sorry. 7, 10, 9, okay, looks correct. We need to make sure something. N rows, M columns, okay. Should be fine. Let's submit this. Okay, we got accepted. Which the verdict is Happy New Year during end of years. Yeah, Codeforces is trying to be funny. So let's solve problem B. We have disjoint ranges of integers. Okay. Number D. Okay. Okay. So we want to know what's the number D that is chosen for each turn. Is that what the question is? Okay, we can show that the number. Wait, we want to D and then removes SLR and then puts into S. Okay, so basically Alice choose a range and Bob choose a number within the range, and then all numbers, and then that number is not put back into S. Okay. Okay, got it. Okay. Okay, got it. I see. Okay. I see. Okay. So we can go from the, wait, what? Oh, I see. Can always go from the one that is the fewer. So we know that this must be the last, right? Yeah, the last one must have just one element. And then yeah, we can wait, can we do that? Yeah, I guess we can always I think I'm overthinking this one. It shouldn't be this complicated. Wait. Picks arrange all R from the set S, and then wait, what happened if the okay, yeah, I think you can yeah, you can what is there? So can lines in any order. Good. So we can reverse the order. We can shuffle the order. Oh, come on. Yeah, and I think I want to sort this based on the length. So I want to pick the one that is that has the fewest amount of element. So do something like this. Okay. And then I can just print it. See, yeah, should be correct. So it's 111 222 233 131 11 44 366 162. Okay, just compare the first three samples, but should be fine. Let's just submit this. Yep, got accepted. Let's move on to C. And hips. The ice hip has HI stones. Okay. Okay, move from height to height minus 1. Okay, 2D from height to height minus 2. Okay. Okay. Okay, you can choose the same. Okay, what's the number in the smallest heap after the process? So we want to maximize the minimum. Okay. Okay. In this case, okay. So we want to move D to the previous one and 2D to the previous one. Okay, got it. Okay, got it. Okay, so let's see. We can do usually when we have this maximize the minimum. Usually we try to binary search. So binary search the answer. So we try to see whether we can do X, and if we do X means that all heaps must have more than X at the end. And then if X is possible, we try to increase it. So let me see. Yeah, I think we can do that in this case. So yeah, because if we are trying to have all heaps has more than X stones or at least X stones, then every step on the way is forced. Like when we are processing the third heap, we want to choose the smallest D such that wait, can we do that? Such that the first heap is at least X. Wait, no, that is not forced. We can wait. Is it beneficial to choose a larger value of D? In this case, let me try to look at the examples. Move 3 stones from 6. Wait, what? And 6 from the third. Okay. Move 3 stones and 6 from the third heap to the. Okay. Okay, got it. So we're moving. Yeah, again, I might be overthinking this. Let's see. Can we do dynamic programming? No, the constraints are too high for dynamic programming. Um, so let's say, yeah, it might be. The problem with the binary search is it might be beneficial to, even if we know what's the target, uh, we might choose in every step of the way. We might choose a greater value of d than what is necessary for the I minus 2 heap. Or maybe let me think. How many people have solved this? 16. Okay, let me try to increase the beat rate because the quality of the stream is bad. Yeah. I'll end the stream a bit. I'll turn it on again to increase the beat rate. Let's see whether that. Okay. Sorry about that. Yeah, I think the stream quality is better now. Yeah, and let's continue solving the problems. Yeah, sorry about the technical issue. So we were solving problem C. Okay, so let's see how can we solve this. Uh, so if we have this, so if we know, if we do binary search and we want every heap at the end has greater is at least the target, then we know, like when we are processing this, the third heap, we know what's the smallest value of d that we must do because we need to increase this by at least t. But we can choose a bigger value of d if we want to increase this one as well. Let's see. Performing the process following process once. You can choose d. Move these stones from ith heap to okay. Okay. Or actually we can do it we can do it from the back instead and make sure that this has the of at least the I think that's the right way to do it. Yep. Because now it's forced, like we can just keep we can just send the maximum that is allowed, so that what am I saying, so that the remaining stones on the pile that we are processing now is not. Wait, can we do that? Yeah, I believe we can do that. So that oh wait, but when you can only pass what's the initial value of this, not after it was added from here. Okay, yeah. what's the I think it cannot be more than 1 million, right? Because it cannot be more than HN, the answer. Okay, so we do standard binary search, and then if we can, then we try to increase the value and set our answer, and then we need to implement the can and then the way to do this is we need to look from the back, and then every time we check what's the most value of D that we can pass on, and it's the minimum of the initial value, and we must to ensure that after we do this, after we pass on this D, it's not less than X, so we must do this. Yep. Okay, and we want to increase this by 2 minus D and increase this by D. Yeah, and then yeah, I think this is correct. Wait, let me do. Yeah, we can do, if this is less than X, then there's just no way. And then we also check for the two initial index. This is 3. Okay, and this is just no way. Okay, then we don't need the max 0 now. Yeah. More than that. This is positive. Yep. Okay, this should be correct. $19. How can we get 19? How on earth can we get 19? This is 3. This is 2 plus D. If it's less than X, we return 0. How come we get 19? Okay, we need to debug this. How is 19 true here? No, it's false. If it's false, what? I see. I forgot to reset the app. Yep, 7113. Okay, let's just submit this. What kind of mice do you use with the Mac? Yeah, I'm using the Magic Mouse, Apple Magic Mouse. We got time limit exceeded. That's weird. Yeah, and I think earlier I saw some people chatted about problem A. I do not need to use simulation. Yeah, probably that's true. But in the time, I just implement what I can. I think of, and yeah, I just do a simulation because that's simpler. Yeah, I think now that I think about it, the math for problem A, the constant time solution might be simpler to code, but yeah, I think I need to figure out the math and might take some time. Yeah, just and initially I thought like the movement is not 1 1. I thought the movement, the unit of the movement is in the input. So yeah, I didn't think the math is going to be easy. Yeah, this problem A. Yeah, I thought this is the initial position, not the direction of the, not the unit of the movement. So yeah, that messed up with my thought thinking process, because I thought yeah, the math is going to be complicated and I can simulate it, so just why not we simulate it. Okay, now I got time limit exceeded on this. Is it possible that we get overflow somewhere? Oh, I see. I must not do memset because there might be several test cases, and if there's a lot of test cases, this memsets will kill me, because it takes a constant amount every time. It will take 200,000 operations every time. So yeah, I think that makes sense. Let's change this to just do it manually, and yeah, we got accepted now. Okay, so let's move on. So we got 2 more problems. Yeah, I'm seeing the chat as well while I'm solving the problem. So if you have anything, feel free to put it in the chat. Please don't spoil problems solutions. It will not be fun anymore. Okay, so problem D. I mean, solutions to problems that I haven't solved. These 2 problems here. The rest of the problems, if you want to share your solution, that's fine, because I have solved it. Okay. So this is similar with A. The probability is introduced and the constraint is different. Okay. So okay. Okay. So at each second, instead of like it always cleans the whole row and column, now there's a probability. Okay. The expected time, okay, got it. And the constraint is now much bigger. Okay, yeah. Makes sense? Got it. Okay, so now I think we have to solve the math. We have to figure out what's yeah, we have to figure out in constant time what's the, maybe not necessarily in constant time as well, but I need to figure out like the cycle length. I can probably do it in linear time as well, because the, yeah, this is n times m, that is smaller than 10^5. But anyway, so let's see. So in this case, there's a fourth, and every time there's a fourth probability of its cleaning, then it becomes, wait, what? So it becomes fourth times 0 plus 3/4, 1/4, 1, 3/4, 3/4, 1/4, 2, something like that. And this becomes 3/16, 1, 9, 64, 2. This becomes 18. Then 256. 3, 81. So basically this is a geometric ratio. No, wait, what? No, sorry, should be, wait, what? No, the expected value is in 3/4, you get 0, but 3/4 of time you get this. So this is 0 plus 3/4 ex plus 1, 1/4 ex equals to 1, ex equals to 4. I missed something. The first movement of the robot is before the robot starts moving. Oh, this is 3/4. Correct. So this is 3/4. This is 3. Okay. Okay. Yep. Yeah, I think we can do basically what I did, but instead of we start with 0, and this 1 is a variable depending on what's the cycle length, right? And basically, if we have, let's say, n times m, and then this, yeah, the issue is the cycle length is different, but it will cycle. So the length of the number of seconds that is possible to clean will be different. So like let's say this is the dirt. So after taking X number of seconds, it can clean it. But then after taking Y number of seconds, we can clean it, and these two might be different. And then the next time, we might take Z, and then might take another number, but we know that it will definitely cycles, right? So after several iterations, it will worst case, it will go back here. It will go back here. Okay, let's assume that at the first second we can clean it. So if the input is here, let's just move it to the input here, and then later we can just plus X to the answer. Yeah, because that's how expected value works. If all of them we reduce by X, then we can just compute it, and then later we increment by X. So after doing all this computation, later it will go back here, and then the cycle length, and then the time that it takes to have another opportunity to clean it will cycle, will go back to X. We can take advantage of that. They might not be that simple. So yeah, if you know all this length, if this is constant, then we can do it with basically the one that we did previously, where we basically say in P over 100 there is a probability that this is clean, and then in 1 minus P over 100 there is a probability that we need to take the cycle length, let's say. But the problem is the cycle length is not constant, depending on, not the cycle length, I keep saying cycle length, but basically like the time that it takes to have another opportunity of cleaning this. But the problem is this is not constant, depending on where we are and the direction of the robot. Which I thing what we can do is we can just basically keep extending this until this cycles. So basically, let's say x, y, z, and then it goes back to x, y, z, something like that. Then we can do p over 100 0 plus 1 minus p over 100 x plus, no sorry, 1 minus p over 100 p over 100 x, 1 minus p over 100, I mean of course the 1 is here, you got 1, square p over 100 x plus y, and then we do 1 minus p over 100 cube p over 100 x, y, z, and then because after this is loops, we then do the 1 minus p over 100 fourth ex plus xyz. Is this how do we do this? Something looks wrong. Something just looks wrong. No, sorry, I shouldn't need this. And then what we can do with this is constant, so you can just compute what's the value, and then this becomes, yeah, basically the previous one where I put this becomes ex 1 minus c, and then cx plus y plus z, and then you solve for ex. How many people have solved this? 11? I can take a look at the standings, why not? Okay. Yeah, I need my my integer division integer modulo library. Bam. Okay. Mod is 10 power of 9 plus 7. Okay. Test case is 10. Okay. Yeah. You guys can see my notes, right? I hope you guys can see it clearly. Okay. Yeah. So we're going to implement what I was thinking. So basically, we want to have NMRB CBRD CD P. Okay. And we read all these values. And then we can, okay, this is annoying actually. Let's do this, so we don't have to worry about so P is the probability that it cleans up, and Q is the probability that it's not, and then we are going to do a similar thing in in problem A, we can actually probably copy paste some code from problem A here. Okay, but this time I need to know whether this place has been visited. Because I want to do the cycle finding. Wait, I need the oh, come on, I need the direction as well. Okay, so pos becomes RBCB, and what's the initial direction? 1 1. Okay. Okay, so first I want to do the same thing as problem A, because as I say, I want to know I want to move the input to a position where we can clean it at first second. So if the input is here, I want to move it here, and then later we add the value by X. And then once we do this, we can actually yeah, let's just do that way. It's simpler. Okay, and then we actually do this thing again. Come on. To go one step, and this is one. And then if we can hit it again, we check whether this has actually been visited before. So it's annoying. Not NXT, move. Yeah, because move can be negative. If I want to make it an array index, I have to plus by 1. If we have visited this before, wait, is the cycle guaranteed to be at the beginning or not? So let's say, can it do something like, what I'm thinking is that, is the cycle guaranteed to start from here again, or can it start from like here? No, right? Because if we want to go at this direction, then it must be from this direction as well, which comes from here. Is that true? Yeah. Okay, so if that is visited, then we can actually break this loop. Will this take forever? No. No. This won't take too long. Okay. We can break the loop here. If this is visited, we can break the whole loop by my notes before. We can do this, and this. And this is third. Yep. So this becomes cur, and then we can solve this by this minus this divided by this. Huh. Divided by 1 minus curve, and then we have to add with the initial value from here, and then we can print and then break, and then if it's not visited before, then we have to add one of this. Oh, come on. Wait, no. So this whole thing, this plus this whole thing, wait, why can't I do math? Wait, if you have ex equals something plus q times ex plus something, then this ex becomes, this is qex plus qk, this qex becomes there. Oh yeah, so this is divided as well. So what we need is actually this plus curve times additional, and we want to divide this by 1 divided by curve. Yep, and then we divide this thing and this by this. And then at the end, then we add that. Yeah. This additional is curve is 1. We want to add P times curve times curve is this, P is this, and then additional. Is this correct? I'm doubting myself. No. This won't compile. Yeah, definitely won't compile. Move is ambiguous. Of course. Segmentation fault, of course. Where is this segmentation fault? Where does this break? What? Wait, what? I can't even read these values. No, something is going wrong. How come my testing does not print? Sorry, not testing, should be debug. Oh my. I forgot to own macros. So it all appears, which means something goes wrong here. Wait, now it doesn't appear, the fourth one. That is weird. Oh, I see. Wait, what? No, I don't see it anymore. Yeah, I should learn to use debugger. Probably. So this appears here. Only once. So it's 1 1 and then it's 2 2, so this is true, and then it crashes somewhere here. Ah, I see, because it's come on, it's one base index. 3 3 15 15, and then the large numbers are wrong. Of course, how do we debug this? 5, 5, 10, 5, 5, 10, 10. Huh. How much math did you take at NUS? Not much, because I took computer science. Actually, I did minor in mathematics, but that just takes like 4 additional mathematic mods than what computer science majors take. So yeah, not much actually. So in total, I think I take 6 or 7 mods, mathematic mods, during my 4 years at NUS. Okay, so this is let's see what might go wrong here. Come on, how do we debug this? This is not fun. From 1 3 to 2 2. So once that reaches the oh, I see. I don't have this. No, the answer is different. Oh, come on. Can I see the standings now? 43 people have solved it. Oh, now it's all gone wrong. Yeah, something is wrong. This is too bad. Or maybe I should do this at the end. Wait, that's weird. That is weird. Just So this additional will be 0. Okay, I need to look at this one. Look at here for an additional maybe. Okay. So this additional should be 0, so that shouldn't be a problem. Okay, and then the next one, it's so this, the answer should be 0 plus this is 1 and then this is 1, and then we go to the cycle. One minus, oh, I see, this, the first time this shouldn't be called. Yeah, this should be at the bottom. Yeah, okay. Yep. $17. Oh, come on. The rest is okay. Only just one this test case. Ah, I see. Yeah. Okay. Got it. Yep. No, not here. Come on. Yep. Okay. Yep. Okay. So last problem. Let's take a look at the standings. Why not? Okay. Middle duplication. We have a binary tree with what am I saying? Binary tree of n nodes. Nodes. Okay. Rule is 1. Each node has no child. Okay. Basically, m was 2 children. Okay. Of the labels of the nodes in order. Okay, basically this is what do you call this? In order? Yeah, that's what it says. Okay, so each node as a label, which is a one character, English Latin character, and then we can choose k nodes to duplicate. We can choose k nodes such that the label is duplicated, and then we want to minimize the in order of the tree. Okay, got it. And then here it's so let's try to draw the tree, or maybe they draw it for us. Okay, yeah. A B, and then k in this case is 3, I believe. Yep. Wait, what did I press? Reload. And then yeah. And then here we want to duplicate this one and this one, so that becomes AA, and then yep. And then yeah, okay, so that's the problem. Okay, got it. Let's see how we can tackle this. So usually when we are given a tree and choices of choosing some nodes, we immediately think of dynamic programming with trees, where the state is usually like the node and then number of nodes that you can choose within that subtree. But in this case, I think we have to do it in linear time. So maybe that's not the solution, because usually those kind of DPs take at least n times k, or sometimes even n squared times k. So yeah, I think that's not the solution for this problem. So maybe we should do greedy, which in lexicographical solution usually it's greedy, because yeah, every time we want to find a lexicographical solution, we must minimize the first character of the output. So yeah, without even thinking the rest of the string. So if there's a choice where the first character is different, we have to choose the option that minimizes the first character. So in this case, let's say instead of this BA, this is A and this is B, then if we choose to duplicate this node, we get AAB, where if we don't, we got AB, we got AB something, right? So in this case, we must duplicate this node because we get AA something, right? Well, AAB something. We don't need to care about the something because AAB is obviously less than AB. Okay, so if this is the other way around, this is A, this is B, we must duplicate this node, regardless of what happened in these nodes, right? And if it's this case, then we actually need to do the other way around, because if we duplicate this, we got BBA, and if we don't duplicate this, we got BA something, right? So that is for this simple case. But if the tree is bigger, then we can actually do that. We just look at the first two nodes in the in order order. And then yeah, again, this is D, this is A. So if this is D, then we must not duplicate it, because if we duplicate it, we got DDA. Whereas if we don't, we get DA. But the question is, what if they are the same? Then the information about these two nodes are not enough. We have to look at the bigger picture, because if these two has the same label, then whether we want to duplicate it or not, the first several characters are the same, right? So yeah, we need to maybe save the K for later for other nodes. Okay, that is the complicated part. Okay. Okay, so that's what I'm thinking with this problem. But yeah, obviously it's just a basic idea, and if there are lots of duplicates, then it's going to be a mess. Let's see. Yeah, I'm not sure why they must do this tree representation thing. They can always just give the input like this, right? Or are we missing something? Yeah, they can just always do the input in the string, and so once we get the value of fu, if there's no duplicated string, then we can just throw out the whole tree, and then the problem now becomes each character can be duplicated, and then we want to choose k characters to be duplicated, and then we want to minimize the lexicographical value, and that would be simpler, I guess, because yeah. Then the question becomes, we want to duplicate if it's increasing like this, right? So if the string likes decreasing and then it increases, something like that, we want to duplicate all this. And then the next time it increases, we want to duplicate this again. Because by duplicating this, this is extended, and then it becomes lexicographically smaller than this. Yep. I think that's how the solution is. So we just try to find what's the pre-order. One is always the rule, right? Okay, good. And then we DFS. If Lx is not -1, we DFS Lx, and then we get the x, and then we DFS to the right. Okay, from this we got the FU if it's not duplicated, which in this case will be BAAB, yeah. And then from here we can do is let's do resum. We try to look through the rest, and then if we see something increases, let's do one. If this increase from the before, then we need to duplicate this, right? Then we can count how many occurrence. What am I doing? I minus CNT is greater than 0, and rest I minus 1 equals I minus CNT plus CNT minus CNT. And then what we can do is we can okay, no, the other way around. Sorry, CNT, should be CNT. Okay. Now the question is if we still have leftovers. Oh, come on. If we have leftovers, wait, do we have to use exactly K or at most K? At most K nodes, okay. Oh, come on. Press 0. Wait, why am I not duplicating this thing? Why am I not duplicating the AA? This AA should be duplicated. CNT 0, that cannot be. Oh, come on, this should be rest I minus CNT. Yep. Okay, why do we duplicate the K instead of the C? Why don't we just do CCYAN instead? Wait, what? That's why. Now, yeah, this is why we should read the problems carefully. So okay, the set of nodes that the label is duplicated must form a must be connected from the root. That's why. Okay. Now the structure of the tree is important. That's why. Okay. So you want to duplicate this C, then both of this A and K must be duplicated as well. Oh, that's annoying. Okay, what can we do? Okay, we know that we can greedily take the answer. There are two choices. We can choose this node or not choose this node. If we choose this node, if we don't choose this node, then the rest of the tree is not chosen, right? Okay, then the question becomes, if so we do pre-order. When we visit this node, we can check whether it's more optimal to extend this by checking whether the next, yeah, basically the one that I say, if this is the graph, if this is like, yeah, then this node is actually here and we will decrease, so it's better not to extend this, right? But if this is going to increase, then it's better to extend all of these nodes. If the yeah, we have to increase as many as we have to duplicate as many nodes as we can in this tray, which is basically this, like, let's say if it's 3, then it's this 3. But we have several choices of which node we want to extend if k is less than 3. Okay. Okay, so basically the question now is, if this is the FU, if the string is not duplicated, wait, we have to be very careful. Yeah, if it goes down, then we want to minimize duplication here. It's basically 0. So several of these nodes, let's say this is 3, this node must not be duplicated, right? If it goes down, right, if it goes down, then this node must not be duplicated. If it goes up, then we have to duplicate as many nodes of this as possible. Okay, so let's say this goes down, so we must not duplicate this 3 node. Let's say this is 1, 2, 3, 4, 5, 6, right? And then we have this, this, and this. We want to duplicate as many nodes of this as possible. Which, if k is 1, then we duplicate this. But what if we have choices? Wait, 1, 2, 3, 4, 5, 6, correct, yeah. Let's say this goes down, so we don't want to increase this. Then let's say it goes up. 2, 3, 4, 5, 6. Let's say this is the same and then it goes up. So we want to duplicate as many of these nodes as possible. Right. If we have two choices like this, Let's say we have duplicated these three, right? And the input is AAA. I'm sorry, AABBBCC, and K is 4, no 5. Let's say 5. First, because this is AAA, we have to duplicate this node, right? So we get AA, and then because we want to duplicate this node, we have to duplicate this node as well. Then when we want to duplicate this, there's a question of whether we want to duplicate this or duplicate this, because we cannot duplicate both at the same time. In order, okay. K is now 2. Can we just always implement this one first? Because Is this live or pre-recorded? This is live. Yeah, I'm seeing the chat. Yeah, I was thinking about how to solve this problem. Sorry if it's boring, but yeah. Hmm. How much question it took me to feel confident about solving diff 2b question? Yeah, I guess it yeah, I guess you should try practicing solving diff 2b questions in different rounds. If you can solve, like every time you open a new round you can solve it, then you can feel confident basically. Yeah, so I guess, yeah, do as many diff 2b question as possible, and then you'll get a sense of how you can solve diff 2b question next time. Although the level of diff 2b question varies, but yeah, I think that's a good approximate. Okay, I think I get a sense of how to solve this question. So basically we can yeah, the idea is still the same. So basically, yeah, for those of you who missed the stream earlier, I mistakenly tried to solve this problem where I did not read of this constraint. So basically I thought like the structure of the tree is not important, and we can choose random nodes. We can choose the nodes in any way we like. But turns out that there's this special condition where if we choose a node, then the parent of the node is has to be chosen as well. Or and yeah, I've been in this problem for a while, so I might need to explain what the problem is for those of you who have joined. So basically we have a tree, and each node there's a label, one character label, and we want to we can choose some of the nodes so that the label is duplicated, and we want the in-order representation of the label to be lexicographically smallest as possible. So in this case, if we don't duplicate any label, the in-order representation is BAAB, right? Because how you do in-order representation is you do whatever in left first, and then you add, and then you append it with the label of that node, and then you append it with whatever representation is on the right subtree, or the tree is binary tree, by the way. Yeah, and then so in this case we should duplicate this node so that we got BAA right? And then in this case, yeah, it got more complicated, but yeah, that's the problem. Okay, so initially I thought that we can just I'm not aware that we have to when we choose a node, we have to choose the parent of the node as well. So I thought we can just greedily take A, and in this case we can duplicate C as well here, so that it becomes DAARKCCYAN, which is smaller than this. But actually we can't do that, since if we take this node, we have to take this node as well, which is more than the allowed number of nodes to be chosen, because there's a k as well, where k is the maximum number of nodes that we can duplicate. Okay, but I think the idea is still the same. So or the way that I tried to do previously is that we look at the string, and then if this sequence of character is smaller than the sequence of the characters that is following it, so in this case is AAB, because A is smaller than B, then we try to extend these characters as many as possible, so that because yeah, so that the occurrence of B is as further away as possible, and that's how we lexicographically minimize a string, right? So I think the idea is still the same. So for each node, we try to see whether we want to extend it in our initial way, in our initial idea, and then so in this tree, instead of having K and A, I have A and C, and then I can DFS the tree. If I visit the left, and then I always go to the left one first on the DFS, and then here in this case I see A, that I actually want to extend it, and then here I know that all the parent are actually greater than him, the in order index, so I can actually just do not care about the parent, and I can just extend this node. Yeah, thing. But then if I chose not to, let's say this, because I don't want to extend it, let's try to write some code. Okay, so I know what's the okay, instead of the character, I need to know what's the index of the in order, right? And then instead of this, I want to know extend. Okay, if this is greater than this, then I want to all of this, I want to extend it. Okay, then I want to extend res x. Okay. So now I should get 2 and wait, what? Sorry, push back. Right, gets infinite loop. Oh, of course, I want to minus x as well. So I want to extend no, I don't want to extend this. I want to extend this and this and this. Okay, no, I don't want to extend this actually. Why is the 0 1? Two, 1, 3. 0. Oh, of course, this should be S. And this should be S as well. Okay, so now I want to increase this, this, and this. Okay, that's fine. Now I can do another DFS. DFS. Okay, so this is what we want to extend, but we might not be able to extend all of them. So we want to store what we actually extend it. And then the way that we do this is if we want to extend X, then yeah, then we less than K, then we can actually we want to extend both this and this. I guess we don't need to. Okay. Why do we duplicate the day? So we duplicate 1 and 0, that's correct. Oh yeah, should be res I. Yeah. What's the difference? Why don't we duplicate at all? Oh, because the day is here, we don't want to duplicate this, so we cannot duplicate all this. And then, oh yeah, that makes sense actually. So let's submit this. Why does it take forever to submit? It's running. Yep, it looks correct. Yep, we got accepted. Why don't we get Happy New Year this time? Okay, now we got Happy New Year. Yep. Okay, so that's this round. Yeah, so the idea is basically the same. We initially indicate which node we want to extend, and then from the root we do DFS, and then we always go to the left first. And then if we want to see a node that we can extend, we try to extend it, and we check whether we can actually extend it, because we have to extend all the way to the root, and that takes yeah, that takes like the depth of that node. But if you already extend this, then when we DFS, we don't actually need to count this, but we can just subtract it. We can just reset from 1 the depth of this. Yeah, and then yeah, this is how the solution for this problem. Yeah, and then if we don't want to extend this, then we must not extend any of this node as well, because this, the way in order works is the index of this is smaller than this. So yeah, this takes priority if whether we want to extend this node or not. Yep. Yeah, so how do you feel about the round? Yeah, I think it's standard div2 problem, standard div2 rounds. I think the problems are quite interesting. Yeah, I mistakenly initially thought that E is simpler than D because I missed this sentence, but yeah, once after I read this sentence, then this problem turns out not to be as easy as I thought. And yeah, I think the problems are balanced, are where it's supposed to be. Like problem E is supposed to be E, D is supposed to be D, and so on. Yeah, but yeah, I think, I don't know, maybe problem A, the statement can be shorter, because like problem A usually yeah, I don't know, maybe it's just me that prefer short problems because it's supposed to be easy, and yeah, I don't want a problem where solving it takes longer than reading the statement. But yeah, I think otherwise it's been a very good round. It's been problems are okay, are interesting, are okay. So yeah, I have nothing to complain actually about this round, other than probably again the statement of problem A. Yep. I have a question about IOI problems. Yeah, I don't know whether you know that I will be involved in IOI 2022, and of course I can't talk about the problems. But yeah, we have got some submissions. Oh, this is your round. Okay, thank you for organizing this round. Yeah, sorry I missed the actual round, and sorry that I probably used your round as a trial for my stream. because this is my first time doing a stream, and I posted in Codeforces, and there are technical difficulties earlier. I'm not sure whether you are here earlier, but yeah, there are a lot of difficulties that I'll try to improve later for future rounds. But yeah, thanks for the round. Yeah, sorry, going back to the IOI problems. Yeah, I've the committee have received some submissions from the community. So thanks for that. But yeah, the call for task is still open, so please try to submit them if you have some ideas, and we of course welcome it. Yeah, but yeah, yeah, I can't talk about anything else about IOI problems. I can't talk about how many have we received and so on, but yeah, we have received some. Yep. Yeah, I don't know what else. Yeah, you guys can ask questions if you want. Otherwise, yeah. Yeah, I don't know what. Yeah, I think I have nothing to complain on my performance as well on this round. I think, yeah, like this takes an hour because it's not. Yeah, it's really a task that maybe takes me an hour. It's not because I overthink it or something. I think it's the problem is just not so trivial for me. And then there's I make one wrong submission here. I forgot what's the bug. I got TLE because of the reset. Yeah, this is what I don't really like about inputs that have multiple test cases, because I can't really do mem sets. Yeah, when you do like the sum of the number of test cases can be big, but the sum is guaranteed to be something. Yeah, I can't do memset on this kind of problems. Yeah, yeah, I don't know. If t is small, if t is less than 10, then I can still do memsets. But if the failure of t is large, even though if the sum is small, because memset will just basically clear the whole array, and I set the array to be a static size, not depending on what's the failure of n of the test case. So yeah, that causes the time limit. There is fill n. Okay, yeah, that's true. There is also like, yeah, maybe I should use factor or something that I can just, yeah, and put it in a local variable or something so that I don't use global variables. Yeah, of course, there's so many ways that I can do to avoid this, but yeah, I just get used to this kind of coding, and all this not so good practically, but I keep doing it. Yeah, I know it's a mistake from my side that I probably do better, but yeah, yeah, and Codeforces have been doing this kind of things for a while now, especially for easier problems. Yeah, I think I get why, like, you're trying to reduce the number of files, reduce the number of test cases, while still manage to be able to test many different scenarios. Yeah, that makes sense actually, but yeah, sometimes, yeah, again, I don't want to complain much. Anyway, what else? Do you guys have something in mind that we can discuss? Yeah, yeah, like several years ago, I've been doing this kind of screencasts on rounds that I do, but recently I've been uploading gaming videos. Yeah, but now I'm trying to do more CP videos again. So yeah, I hope you guys are, yeah, for those subscribers who subscribe my account for like CP videos, but recently you see more gaming videos. Yeah, apologize for that. Yeah, I hope to be able to deliver more CP contents from now on. We'll see how it goes. How can I practice to solve like you? Yeah, I mean, I can't really say I'm very good as well. There are of course many more programmers who are better than me. I'm probably ranked like 200 or for 300 now in Codeforces. But yeah, I guess, yeah, I don't know, like, yeah, I think these days there are many resources to practice on. Yeah, when I started doing this, it was like 10 years ago or something. Resources is not as many as now, and yeah, now I don't really have time to practice, unfortunately, because of other commitments. But when I do it in high school, I should have more time, but unfortunately the resources are not as many. Yeah, like I think, yeah, of course practice is still what you can do, like just do rounds, even though you can't do it during the contest. You can just, of course, absolve it or doing it virtually like this. And you can also like read the blogs, like recently there are many good written blogs by many coders about new materials that I can't just find time to learn about it, because again, other commitments. But yeah, I think they're always good to read. Yeah, so yeah, you can always and I think, yeah, back in the days we use top coder forums. They are good, but I think these days they are not very maintained anymore. I think these days Codeforces forums are better, but yeah, back in the days, top many lessons in top coder forums are good. I think this you can still find some of them, some of old forums that maybe you can just read for extra materials. But yeah, but I think, yeah, probably it's not worth anymore because they are not very maintained. And I think everything that you can see on top coder forums, you can probably see it in Codeforces forums as well, because yeah, the community is very much bigger in Codeforces now. Yeah, I think I remember I learned sparse table in top coder forums. But yeah, I believe you can find it in Codeforces forums as well these days. Sparse table and binary lifting and lowest common ancestor, those kind of things. I learned it in top coder forum back 10 years ago or something. Discord server, I don't have a Discord server. Yeah, yeah, probably not as famous as like Ericto or something, that every time he streams, like he gets many watchers. So yeah, I don't think it's worth for me to set up my own Discord server. But yeah, maybe if I stream more I and many more people are interested on my Discord server, I can create that, but not currently. Yep. Yeah, for those people who are asking like how to practice, how do I get better, I'm not even sure like whether these are people that actually better than me, because there are so many people that are better than me that I just can't memorize all of the names. So yeah, please don't be sarcastic and ask those questions if you are actually better than me. 'Cause yeah, I don't know which place am I in Codeforces now. They haven't updated the rating from the last round, from the goodbye round. I don't know why. Yeah, I'm probably like 300 something at Codeforces now. 343. Okay, yeah. So there are like 300 plus people, and this also like only the users that participated recently. So I believe there are probably like 500 people that are better than me, that, yeah, in this word. So yeah, and of course I cannot memorize all of the names, and yeah, so many great people out there. Yeah, so yeah, you can probably learn from those people as well. And yeah, if you are one of those people, please don't ask me how to get better. Yeah. Yeah, by the way, if you are not aware yet by now, I've been using this extension that changes the color to to the true color, because yeah, every end of year Codeforces allows you to change your color, so that yeah, red coder can be a gray coder or something like that. Well, I actually used it in the past, but now I try to avoid it because I don't really like it. Yeah, because like I think I have a round in the past where I messed up miserably in the goodbye round. I think it was this, or maybe there's one that is even more messed up. Yeah, I think it was this one. Yeah, uh, yeah. I've always blaming this round because yeah, whenever I see the scoreboard, I can't really see like which programmers are supposed to be above me and which programmers are supposed to be below me because of the colors. And yeah, and this really messed up my yeah, maybe it's a lame excuse, but I don't know. I always believe that this my performance in this round is because the scoreboard is messed up. And and yeah, and because of this, when I participated the just recent contest, it's not appearing in this table yet. I don't know why, but this round, yeah, because I want to participate in this round, I make sure to install the extension, so that I don't get the yeah, I learned from this round basically that I can I need to see the scoreboard as it like in the correct color, so that I know like, oh, if there is uh like an orange rated color, I'm not trying to be uh this like profiling people, but like yeah, I think colors are good heuristics of seeing like, oh, these colored people have solved these problems, so probably they don't require techniques that that is very hard or something. So yeah, that sometimes is a good heuristics, but yeah, again, now with all this magic and stuff, yeah, it messes me up, and I just prefer to install extension so that the colors are what they are supposed to be. Yeah, it's yeah, if you want to install the extension, I think it's called anti magic. Yeah, this one. Yeah. Yeah, thank you very much, Golofanov, if you are in this stream, for creating this. Yeah, this is very useful. So yeah, thank you. There's a chat in Russian. Sorry, I don't actually read Russian, so if you can ask that in English, that should be beneficial. Are you a software engineer? Yeah, I am. I'm a software engineer in a high frequency trading firm now. I used to be working in Google, but not anymore. Yeah, when I was in Google, I actually helped with Google Code Jam and Kickstart. So I think I posted some blogs on the Kickstart. Whenever there's a coming Kickstart round, I posted some blogs. I think nowadays it's Kostka that's doing this, like Bartek Koska. Yeah, he's in Google now, but back then, yeah, he was not in Google, and I was in Google, and I was, yeah, posting some rounds as a reminder, especially if some of the problems are mine, so that people are solving my tasks. Yeah, but yeah, nowadays I think it's Kostka that has been posting all this incoming sorry, that has been posting this upcoming Kickstart rounds. So yeah, thanks. I'm glad you like the extension. Yeah, I don't know whether you are the writer, but yeah. Sorry again. I'm not good at memorizing names, but yeah, if you are, yeah, I really like the extension, and thank you very much for writing it. Yeah, he has been the one that is writing all these Kickstart rounds. Yeah, yeah, I used to be in Google, but not anymore. Yeah. What else? Sorry.
I found a few alignment near you.
Whoops. What is that? Oh yeah, you are the one writing it. Okay, thank you very much. Yep, I really appreciate it. I think it's my Google Assistant responding just now. Yeah. Okay, what else? Maybe does anyone know why the rating from the last round is not updated yet? Yeah, I know there's a Codeforces maintenance earlier today, but is that why? Is that why the rating computation takes a bit longer? Yeah, it's not really important though. Like, yeah, like, yeah, it doesn't really matter actually. But yeah, I guess I'm just wondering why it's taking longer to update rating from the last round. Which is like almost 24 hours by now. No, probably not. Probably like 20 hours or something. It's been 20 hours from this round, and the rating is not updated yet. I don't think it usually takes this long. What else can we talk about? Yeah, I guess there's nothing more interesting to talk about. Yeah, I guess thanks for watching. Yeah, I'll try to again, as I said before, I try to uh put more CP stuff instead of gaming stuff. Yeah, I've been speedrunning some games, but yeah, I'll try to to upload more CP content again. Yeah, I've done it 3 years ago or something. But yeah, I'll try to revive some of these contents again, and probably do more live streams as well. Yeah, if I have time. Hopefully I do, and I will. Hopefully I will have time. Okay, thank you guys. Bye bye.